Okay, let's do the compound worksheet. Okay, I gave you the formulas up here, and then it says 10,000 is saved in an account. So that's a miss there, but so 10,000 is in the starting amount, 20 years, so that's going to be T, which shows up in the power, 5%, which in decimal form is the R, so 5% is 0.05, and so we have A0, 10,000, parenthesis 1 plus 0.05, that's 5% in decimal, over number times compounded annually be once a year, and so n is 1, and so we have 1 times 20. We work that out in the calculator, and we do 10,000 parenthesis 1 plus 0.05 divided by 1 to the power, and since this goes up, we don't have to keep parentheses. If you do it on a calculator that doesn't go up, then you have to do parenthesis 1 times 20, which we could have done in our head. 1 times 20 is 20, and we get 26,532. 26,532, and if this is an account, they would do it to the nearest cents, which would be 98 cents. More than doubled in 20 years. Just for leaving it there and letting the bank use it to make money or whatever investment. How much would be if it was compounded daily? So, and now instead of n being 1, it's how many days in year, which is 365, so n is 365, so we have 365 times 20. So I can go back and change this, change my 1 there to 365, change the 1 there to 3, insert 65, and press enter, and now I get more. We get 27,180. Again, we're talking money, so it'd be 96 cents, rounded off to the nearest penny. And now we're going to compound it continuously, so now we switch formulas to this one, which is $10,000 is the starting amount, E to R in the interest rate in decimal form is 0.05 times the number of years, 20 years, and so we've got 10,000 second e to the 0.05 times 20. And it comes out to be a little bit more than this, $27,182.82 rounded off. Okay, suppose a person wanted to have 15,000 after 5 years. So we don't know how much the starting amount is, but we want to end up with 5,000. So the 15,000. So we have to put 15,000 there, and we've got to figure this number out. So, and this is compounded monthly, so we got to use this formula. So we have ending with 15,000, starting with don't know, 1 plus 12%, so 0.12, that percentage in decimal, compounded monthly, so 12 times a year, to the 12 times how many years? in 5 years. So, to solve for this, we're going to have to divide both sides by this number. Now, I could figure that number out ahead of time, or I could write this divided by that whole expression. I'm going to figure this number out ahead of time so that you can see what that is. So that's parenthesis 1 plus 0.12 divided by 12, close parenthesis, to the, and this is going to be 5 times 12 is 60. Or I could type that in, but 5 times 12. But anyway, that's 1.8166. $96699. So anyway, we've got something like this times A0 equals 15,000. So I got to take 15,000 divided by that answer. 15000 divided by my last answer, and I get, this is how much we'd have to start with. A0 would have to be $8,256.74 approximately, rounded off, to end up with 15,000 in 5 years. What if it was compounded continuously? Well, then we want to end with, how much was it? 15,000 equals the starting amount, e to the interest rate, 12%, for 5 years. So we'll figure out e to the 0.12 times 5, and that's 1.8221188. 1.8221188 times A0 has to be this. So I got to take 15,000 divided by that answer. Divided by the answer, and we get, now I only have to invest $8,232.17 rounded off. Okay, carbon 14 dating. So now we have the amount we had at the end, we don't know, equals the amount we started with, which we don't know, e to the negative 0.000124 t. But we know that 30% of whatever we started with is here. So I could write 0.3 for 30% times the starting amount is the starting amount e to the negative 0.000124 t. And then divide both sides by A0. And that cancels them out. And so we have the other way to look at it. To end up with 30%, this has to be 30% of the original amount. So just this part has to be 0.30. Now to solve that, I suggested that we graph this and find out when they intersect. So I'm going to go to y equals, and I'm going to type in 0.3, and then I'm going to type in e to the negative 0.000124 x. You could do this also on Desmos, and if I go zoom 6, standard graph, doesn't look like we're getting anywhere. But we're carbon-14 dating, which is, it takes 5,600 years for it to be half as much, and we're down to 30%, so we have to get out here to over 5,000, maybe 10,000. So I'm going to go to my window and get X go up to 10,000. And graph. There's the one and the other. And it looks like they might end up hitting each other way out here by 10,000. I'm going to make the window go a little bit further, 15,000. And it's never, the two graphs are always below 1. So I'm going to make it go from vertically in the y direction from 0 to 1. And you may want to do this on Desmos. Do these settings for your window. And now graph, and there's the one and there's the other. And we can see the 0.3 and when it gets down to 0.3. So now I want to find that intersection. So I can calculate the intersection of that graph, and there's my guess, and there's my answer. And it says t would have to be 9709 years, approximately, for it to be down to 30% of whatever it started at. Okay?